Hello. In this video, we will see a demo of how Levitate can help in tracking the Canary deployments and if the error rate increases beyond a certain limit, along with the event when the Canary was deployed. With that knowledge, it can even help in rolling back those Canary releases as well. So the workflow that I'm going to talk about will have this kind of a data flow. There will be an application orchestrator. I'm using a Kubernetes-based setup with Argo CD for rolling out the Canary deployments. For any event of rolling out a Canary, there will be a deployment event that will be sent to Levitate over the HTTP REST API. Along with that, the application will keep emitting its own metrics that will be scraped by either a Prometheus or a Prometheus agent and then remote return to Levitate. So Levitate will have contextual events about the deployment, when it started, when it stopped, when the canary started, when the canary got promoted, and so on. And it will also have the other regular metrics such as HTTP metrics and the application metrics. And then Levitate will provide us the information whether the canary is successful or not, which we can take a decision in our Argo CD setup to decide whether to continue with that canary or not. All of this is an automated setup, so we don't have to do any manual step apart from just triggering the canary deployment and like causing some traffic flow so that the automation kicks in. So I'll tell you how the flow looks like right now. This is the sample app, and as you can see, I'm running it against a stable version. Right now, I'll just roll back here and then we'll start from scratch. So it goes via the 3 to 4 stages. We'll first roll out the canary to 20% of the users, then we will roll it out to 40% of the users, then we will roll it out to 60, and then at the end, we'll roll it out to all 100% of the users if things are going well. Now, while the canary is deployed, there might be some traffic coming to the application. Let me just quickly show you how I can simulate that. So while the application is running, I can just send a request here along with the header for Canary to be set always, and that will mean that the request is going to Canary. If I remove this header, then it will either go to stable or to Canary. Like you saw here, 2 requests went to Canary, 1 request went to stable. So that is the setup for success. And then if I want to create an error condition, which is useful for this demo to demonstrate how degradation of Canary can be tracked by Levitate, I can just send a localhost error request, which will cause an error. So this is how our setup would be. Let's come back to how the analysis will be done. So what happens is we discussed here that while our application is running, while the Canary deployments are happening, we will send certain deployment events to Levitate. And in our setup, we are going to progressively roll out to 20, 40, 60, 80% of the users. So let me just quickly jump to a Grafana, which is connected to my Levitate data source. And here my service name is sample service. And the domain events or the deployment events are basically captured by this metric. If I want to see them over time, and this was a while back while I was preparing for the demo, but you can see that I can see that the 20% rollout was started, then it was stopped, because we moved on to the 40% rollout. Then after that, we moved on to 60% rollout and so on. So I can see all of those events getting tracked here as a metric because again, Levitate is a metrics and events warehouse, but can also convert these real-time events such as deployment events into metrics as well. Now, how do I measure the success of my canary, right? So that for that I have a simple formula. I measure all the requests where the success is true over the total requests that are coming. And if I quickly run this, I will see that. Let me just stop showing the previous one, the event. And here I can see that things are looking okay. There are around 0.833 errors, or the success rate is 0.833 as of now, which means 83% of the requests are succeeding. And because of that, I think because of the one error that we sent while trying it out, I think that was the only one which failed. But otherwise, rest of the requests are succeeding. Now, this was about the total success rate. How do I tie it to the success of the canary, right? Let's see that as well. So for every step of the 20, 40, 60%, we have defined a promql, which basically combines the success rate as well as the deployment event itself, and sees that what was the percentage of errors in context of the deployment event that happened, so that we can quickly figure out whether the canary is failing for 20% of the users or 40% of the users or 60% of the users, right? Because not necessarily the canary will degrade right away when we roll it out to 20% of the users, because there might be lesser number of requests that might be coming. But for 40%, it may fail if the errors increase beyond a certain limit. So these are the queries. And what we have done is that we have combined these queries in the analysis template itself. So this is the analysis template that basically is used to evaluate the success condition of the canary. And the success condition is that any of these queries fails because all of them are combined using or. Any of these basically fails, then we will have the canary as failed. So even it fails for 20%, it fails for 40%, or it fails for 60%, our canary will fail. And what that means is that our canary has been degraded. If this happens, because this is part of the analysis template itself, our deployment in Argo CD will show up as degraded. Right now it is in progress because we have moved to the 60% condition. But we will try to simulate some errors and see how it can be degraded. So let's do that. Let me just restart this one more time, and then we can see, we can try running more errors and see that this goes into basically a degraded state. Let's try our canary with an error condition now. So we'll try to create some chaos so that the canary fails. And for that, we're going to restart the process. Earlier, we were basically successful in running the canary. It went through all the steps. And after that, I caught certain errors here, which basically meant that the canary started failing, and I could see it here directly, where now it has been restarted, right? So what that means is that it is going through all the hops again. It went through the 20% and the 40% as of now. Let me also send a couple of success requests in between, so that we can see the percentage of errors in our Grafana. So the first metric that we wanted to see was success rate. Let's see what is the current success rate. For that, I'll just refresh this page. So the success rate here seems to be very low, 0.0909. What that means is that I sent too many error requests basically, which caused it to fail. But if we see the success rate for Canary 20, it has also reduced massively. In fact, it has almost become zero right now, right? And the same will be the case, I think, for the 40 and the 60 percent as well. In fact, it has not even gone there because it has already failed. So if we go back to our Argo CD deployment, by this time it has already failed. Just in front of our eyes, this change from in progress to degraded. And the reason for that was because of the error conditions that I had created, which ran this analysis template. And then because of the analysis template was configured to read data from Levitate, combine the error requests along with the domain events for deployment, and then it flagged as flagged the canary as failed. So this is how we can basically use Levitate's domain events along with the other metrics and take decisions related to deployments, take decisions related to whether to continue with the deployment itself. And all of this can be automated as well because we didn't take a lot of manual steps in this scenario, apart from just running the call requests and like going through the dashboards and seeing the performance of the Canary. So this is how powerful it is to basically combine these contextual events along with the metrics that our application submits. And these contextual events can be anything. They can be deployment events, they can be CI/CD events, they can be configuration related events, and all of them can be combined with our real-time metrics that are emitted from application and infrastructure components, and then use them together to take better decisions. Thank you.